We have the limit of 1 over e to the x as x approaches 1. And I'm claiming it's equal to 1 over e. Well, you just take the 1, do the direct substitution, plug it in, and e to the 1 is just e. And we can't really do much more with that. Therefore, our limit's equal to 1 over e. Okay, we have the limit of 9x plus e to the x, and as you can see it's all in parentheses as x approaches 1. And so I do the direct substitution, plugging 1 directly in where there's an x. Now we have the natural log of 9 plus e to the 1. Now the natural log of 9 can be rewritten as the natural log of 3 squared. And this is the properties of limits, where you can take this 2 and bring it directly out in front of the natural log. Now either one of these answers is really correct. However, this has just kind of been simplified about as down as far as you can get. So we have 2 times the natural log of 3 plus e. Now we would never really write e to the 1. We just simplify it down as e. Okay, we've got the limit of the natural log of x over e to the x as x approaches 1, and I'm claiming it's equal to negative 1. We just do the direct substitution, plugging 1 directly in. Now I can rewrite this by the properties of the properties of natural logs. I can break this up as the natural log of 1 minus the natural log of e. The natural log of 1 is 0, and the natural log of e is 1. And this all reduces down to negative 1. Now, if you're just not sure why the natural log of 1 is equal to 0, what you can do is get your calculator out and just put in your calculator, type in the natural log of 1 or the natural log of e. Okay, we have the natural log of e to the 2x minus 1 over e to the x minus 1 as x approaches 0. And I'm claiming that this limit is equal to 2. Well, first thing I'm going to do is the direct substitution, plugging 0 in for x. And as you can see here, we end up getting 0 over 0. Now remember, a number raised to the 0 power is just 1. And so 1 minus 1 is 0. Because I'm getting 0 over 0, that means that what we need to do here is transform this somehow. Because I have an e to the 2x, I can rewrite this as e to the x and quantity squared. So remember, by the powers of exponents, this 2 times x, right, is the 2x here. So I have rewritten this now. Now I can actually factor this. This is the difference of 2 squares. So if you want just to think of this as being 1 squared here, and 1 squared is obviously just 1. But we can actually factor this as e to the x minus 1 times e to the x plus 1. Now we have an e to the x minus 1 in the denominator and 1 in the numerator. So those are going to cancel out, and we're going to be left with e to the x plus 1. Now we can finally do the direct substitution. We plug the 0 in for where there's an x, and now we have e to the 0, remember, is 1, and 1 plus 1 is 2. So that's the reason our limit is equal to 2.